So in this video, we're going to be working with a new unit to measure the angle that is called radians. We have been used to use degrees, right? We have been used to use degrees in geometry. And degree, we know that in a circle is going to be 360. So that means that from here, if I measure this is going to be 90 to this line. Then from here to here is 90 more. So that means that starting from here is 180 and so on. Keep in mind the following. For trigonometry, we're using my x-axis as my standard initial side. So as a review on geometry, an angle has an initial side and has a terminal side. And the measure of the angle is this distance that is in here. And again, on trig, we name that distance most of the time with a Greek letter, and we use most of the time theta, just as most of the time we use x when we're working with a regular variable. So this opening right here from this initial side to this part, that's my angle. And so on my x and y axis, the standard way of drawing an angle is that my initial side is going to be right on the x-axis, on the positive part of the x-axis, and then anything that I draw from there, I'm going to have this angle right here, and that's going to be my measure. Again, usually we have been using that in degrees. Now we are going to add a new unit that is going to call radians. And the reason why it's called radians is because, as a review, we know that this distance from the center of the circle to my circumference is called a radius. So we're actually counting how many times I can draw my radius on the circumference. That's the name, and that's why it's named a radian. A radian means that on an entire circle, my way around the circle, again in degrees is 360, in radians is 2 pi. Now keep this in mind, that this is important, that when we are converting from one to the other one. So that means that, for example, from here, if I simplify this, right, that means that in 1 degree, if I divide by 360 here, in 1 degree, there's pi over 180 radians. Now, again, if I still use the same one, let's write it again here and go on the other direction and divide by 2 pi on both sides. That means that there's 180 pi in 1 radian. 180 degrees divided by pi in 1 radian. So those are my conversions. So this is important. This is my first conversion here, and this is my second. So let's see some exercise. So it says convert each degree measure into radians. Right, so that means that, again, to go from degree to radians, we're going to multiply times. We're going to multiply times pi over 180. Okay. So again, this is 75 pi over 180. We're going to keep that pi there. Now we're going to simplify. I'm going to simplify by 5. So that means that I got, and actually, not by 5, I can actually simplify by 15. So that means that I got 5 pi over 36 radians. Number 2, again, I'm going to multiply the same pi over 180. So I can cross simplify. Remember that we can cross simplify here. And in this case, I can simplify by 30. So this becomes a 6 down here. The degrees are canceling out. So here's the same on this one. I get a degree sign right here. I get a degree sign right there. So I can cancel those 2 units right there. And that's why it becomes a radians. So here I'm doing the same. I'm canceling this one and that one. So I simplify. So I got pi over 6. Usually when we are working with radians that has the pi already, we don't have to write radians. Okay, so the next one, again, I'm going to multiply times pi over 180 degrees. Again, the degrees are canceling out. And in this case, I can also simplify by 10, so I can technically cancel out the zeros. So this becomes 19 pi over 18. The next one, again, by pi over 180. So on this case, I can simplify here by 45. By 45 right here. So again, the degrees are canceling out with the degrees down here. So that means that this becomes negative 7 pi over 4. I'm going to show you in class how to use your calculator to simplify that fraction. Okay, so the next one. Again, now I'm going to go in the other direction. So the other direction, I'm just flipping that fraction, that ratio. So on this case, instead of multiplying like I did up here, pi over 180, I'm going to multiply times 180 over pi. In this case, again, the pi cancel out. And I can simplify the 3 and then 180. This becomes a 60. And now I'm multiplying 4 or negative 4 times 60. That's the same as negative 240 degrees. Now, on this case that we're rewriting in degrees is important, the degree sign. So we have to include the degree. Let's see the next one. Again, on this one, I'm going to start by multiplying times pi times 180 over pi. Keep in mind that on my numerator, on that ratio that I'm multiplying, I'm going to have the unit that I want. In this case, I want it in degrees. So I'm going to keep the degree here. So I'm going to cancel out the pi, the 12, and the 180 simplified. This becomes a 15, and now I just have to multiply times 23. So this equals to 345 degrees. Again, so here I'm multiplying times 180 over pi. The pi cancel out, and I can simplify the 9 and the 180. This becomes a 20. So I got 20 times 50 equals 2,000 degrees. The last one, again, I'm multiplying times 180 over pi. So the pi cancel out. The 6 simplify with the 180, so this becomes 830. So I got 31 times 30 is 930. So this equals to 930 degrees. And that's it for this lesson. May the force be with you.